What's up, guys? Nitrogen is the seventh most abundant element in the universe, according to Wikipedia. And nitrogen gas is 78% of the air we breathe. It also forms an important starting point for the surfactant supply chain. So let's take a look at a whole bunch of slides. You've seen this one before. Nitrogen from the air plus hydrogen gives you ammonia. Haber-Bosch process, very important for Western, in fact, all civilization. That ammonia gives you different types of amines, which we'll now look at in terms of key building blocks for the surfactant value chain. The first set of building blocks are ethanolamines, mono, di, and triethanolamine. That's ethylene oxide plus ammonia. And then the other key amine building blocks, there's a bunch of them here on this slide: methylamine, dimethylamine, AEEA, amino ethyl ethanolamine, and of course the famous DMAPA, dimethylamine propylamine, all forming important starting points for a range of surfactants, as we'll look at in the next bunch of slides. We're going to go by class here. So for anionics, we've got the torates, starting with ethylene oxide, gives you sodium isethionate, and then that plus methylamine takes you on your way to the torate functionality. Next up, of course, sarcosinates, starting with methylamine plus formaldehyde, giving you sarcosinates. Moving into the cationic class, ester quartz, built on ethanolamines, particularly triethanolamine, as you can see in this slide. And of course, a whole bunch of other quartz, starting from fatty nitriles, which are produced by the reaction of ammonia with various chain lengths of fatty acids. Okay, moving out of the cationic group into amphoterics, betanes, of course, built on dimethylamine, and going through the various intermediates you've seen in this slide, and amphodiacetates and amphodipropianates, going through AEEA, easy for me to say, aminoethylethanolamine, as you can see in this slide. Moving into non-ionics, of course, a whole bunch of amides or amides, depending on where you come from. Monoethanolamine forming the basis here of a monoethanolamide in this slide. And the less well-known glucamides, glucose plus methylamine here, giving you fatty acid and methyl glucamides. And finally, in the group amine oxides, lauryl dimethylamine, here shown reacting with hydrogen peroxide to give you lauryl dimethylamine oxide. And the same applies to various other types of alkyl dimethylamine starting points. And so that's it. An important group of surfactants, maybe not in volume, in tons terms, but certainly in terms of application across the board, household and personal care, and a whole range of industrial applications for these nitrogen-based surfactants. I hope you found this interesting. Please like, subscribe, and please do put in the comments any additional points you'd like to make or suggestions for further coverage in these 5-minute capsules. Thanks again, as always, for listening.